Okay, in this video, we're going to cover probability involving and or, and so let's begin. And so first we need a little bit of background. An independent event. You can think about it like this. You roll a 3, then you flip a coin. So if you roll a 3, that doesn't increase your chance of getting a heads. An dependent event is like pulling cards. And each time you pull and you don't replace, so there's less cards total available. For example, if you pull one card, the next time you pull, you won't have that card anymore because you don't replace. And so we're going to solve these two problems. And so let's begin. The first one says this: probability that A occurs is 1/6 and probability that B occurs is 1/2. So what is the probability that you land on 3 and get heads? So a dice has 1 through 6. So 3 is just 1/6. And in a coin you have either heads or tails, so 1/2. So 1/6 is like landing on a 3 and getting heads is like 1/2. So this is an example of an and. So what we're going to do is multiply. We'll get 1/6 times 1/2 and we get 1/12. So we have a 1 in 12 chance of getting a 3 and a heads. Now visually we'll also show this. So for example we have 1, 2, 3, 4, 5, 6. In each of these cases we get heads. I'm just going to save a little bit of time but just put a little arrow heads. Another example could be this: 1, 2, 3, 4, 5, 6. But we get tails. And so we have 6 cases here and 6 cases here. So our total number of cases is 12. But this problem is very specific. We want to land on 3 and get heads. So 3 and heads is only one time. So that's how we get 1 out of 12. Now this is another problem. It says assume events are independent. Probability of event A occur is 0.4. Probability that B occurs is 0.7. And what's the probability of A or B occurring? Now I'm going to solve this problem in two ways. One way to really illustrate what's happening. So scenario 1, we could say A only occur, so we don't get B. Scenario 2 could be B only occur, we don't get A. And scenario 3 is they both occur, so both occur. And I'm going to draw a Venn diagram. And so A only is just this part right here. B only is this part right here, and both is right here. But if you notice, up to here means A occurs. But if you want to know just A, it's just going to be this area right here. So let's show A only occurring. So the probability that A occurs is going to be 0.4. And the probability that B does not occur is going to be 0.3. Because probability that B occurs is 0.7. So 1 minus 0.7 is 0.3. This is going to represent only A occurring. And if you multiply, you get 0.12. So what this is saying is from here to here is 0.12. Now let's do B only occurring. Same idea. So what's the probability that A does not occur? That's going to be 0.6. 1 minus 0.4, so we get 0.6. And what's the probability that B does occur is 0.7. And if you go ahead and multiply it out, you get 0.42. So from here to here is going to be 0.42. The last one is, what if they both occur? So the probability that A occurs is 0.4. Probability that B occurs is 0.7. And if you multiply it out, you get 0.28. So from here to here is 0.28. And there's actually one more case, neither occurring. So we could say neither occurs. So same idea. So probability that A occurs is 0.4. So probability that A does not occur is going to be 0.6. Likewise, a probability that B does not occur is going to be 0.3. And if you multiply it out, you get 0.18. I'm going to put this on the outside. And now if you add it all up, 0.12 plus 0.28, we're going to get 0.4. And 0.42 plus 0.18, we get 0.6. And so in total, we get 1. So this covers all the scenarios. Now, it's very important what this question is asking us. It's asking us, what's the probability of A or B occurring? And so that's just going to be all three of these cases. So we just add it up. 0.12 plus 0.42 plus 0.28. And if you use a calculator, or if you want to, you could do 1 minus this piece. Same thing. You're going to get 0.82. So the probability that A or B occurs will be 0.82. And we have other information we can kind of explore. Like for example, what's the probability that A occurs is 0.4. If you take 0.12, you add 0.28, you get 0.4. Likewise, probability of B occurring, you got 0.42 plus 0.28, you get 0.7. And really the shortcut, if you want to know the probability of A or B, so this area right here, the shortcut would be this. You take your 0.4, you add 0.7, and you subtract 0.28. You only do it one time. By doing it one time, it will cover this whole area right here. Because the 0.28 is being added to 0.12 and 0.42, but we only want to add it once. So if you do this, use your calculator, you're going to go ahead and get 0.82. So both ways will work. And that's pretty much it for this video.